Hello friends, welcome back to my channel. In this tutorial, we'll look at this question. The integral from negative pi over 2 to positive pi over 2 of the square root of secant x minus cosine of x dx. So, whenever we have symmetric limits from negative pi over 2 to positive pi over 2, we check if our integrand is an odd or even function. So when we look at the integrand is not an odd function. So our integral here is not going to be 0. But if the integrand is an even function, we can split that one into two different integrals, into 2 times the integral from 0 to pi over 2. So secant of x is an even function, cosine of x is an even function. So in that case, the square root of secant x minus cosine of x is going to be an even function. So in this case, we can split our integral. Our integral can also be written as I can also be written as 2 times the integral from 0 to pi over 2 of the square root of secant x minus cosine of x, because this is an even function. So we can just multiply 2 times the integral from 0 to pi over 2. So this is an MIT Integration B question of 2024 regular session quarterfinals. So please subscribe to my channel for more of this kind of content. So let's solve this integral. So we can rewrite this integral like this, and then we have the integral from 0 to pi over 2 of the square root of secant is 1 over cosine of x minus cosine of x dx. And this one is 2, the integral from 0 to pi over 2 of the square root of, we can multiply terms out, 1 minus cosine squared of x over cosine of x dx. And what is 1 minus cosine of x? Cosine square of x. 1 minus cosine square of x is the same as sine square of x using the Pythagorean theorem. So this becomes 2 times the integral from 0 to pi over 2 of the square root of sine squared of x all over the square root of cosine of x dx. And the square root of sine square x is sine x. So the integral from 0 to pi over 2 times of that sine of x over the square root of cosine of x dx. So we can now really do a u sub here, a very simple one. We can let u to be equal to the cosine of x, because the derivative of the cosine of x is the negative sign, right? So du is going to be negative sine of x dx. What about the change in limits? When x is equals to 0, what happens to u? U is going to be the cosine of 0, which is 1. When x is equals to positive pi over 2, u is going to be cosine of pi over 2, that is cosine of 90, which is 0. So our integral really can be taken into the u well at this moment, right? So this is, I can multiply by negative 1, integral from 0 to pi over 2, negative sine of x dx, all over the square root of cosine of x. So this is negative 2. The integral from 0, it's not 0 to pi over 2 now, so this is now the lower limit is now 1 to 0. This is now 1 to 0 of negative sine x dx is du. So that is du all over the square root of u. We can switch the limit, and that will nullify the negative in front. You have 2 integral from 0 to 1 of u to the negative 1/2 du. That is how this one can be simplified. You're now integrating, that is going to be u to the negative 1/2 plus 1 over negative 1/2 plus 1. You're integrating that from 0 to 1. So that is 2 u to the half over half from 0 to 1. And that is what? 4. Because 2 over half is 4. Square root of u from 0 to 1. You can now plug in your limits. So that is 4 square root of 1 minus square root of 0. So that is 4 times 1, and that is 4. So our integral evaluates to 4. So therefore, the integral from negative pi over 2 to positive pi over 2 of the square root of secant x minus cosine of x dx. And this one really evaluates nicely to 4. That is how you solve this one. So when you have symmetric limits like this, you check the integrand. If the integrand is an odd function, that is going to be 0 straight away. If the integrand is an even function, then you split it into 2 by multiplying 2 times the integral from 0 to the upper limit. And that is how you solve these kind of integrals. If you find this helpful, make sure you subscribe to my channel, smash the subscribe button for more engaging content like this. I thank you so much for watching this video, and I will definitely catch you up in the next one. Bye bye.